My dear friends, after a lot of requests, I'm going to bring about another experiment, that is the PN junction experiment, the PN junction VI characteristic graph experiment for class 12. So let's see how it is done. Thank you. So for this experiment, we will require a PN junction kit and a milliammeter, a voltmeter, and some connecting cables. These are the connecting cables. So you see, there is a voltage knob for increasing or decreasing the voltage from 0 to 1 volt here, or from 0 to 100 volt here, which is of course not required in this experiment because we are doing a forward bias experiment. So we'll select 1 volt here. It can be selected 100 volt or it can be made 1 volt like this. Similarly, the milliammeter, here the range of the kit is 1 milliampere or 50 milliampere. We are selecting 50 milliampere. Okay, so this is the milliammeter. The actual kit ammeter and the kit voltmeter are actually out of order, so I am taking some extra voltmeter and milliammeter, which is of course experimental. So now we need to make the connections. Before making the connections, you see what is the least count of the milliammeter. The 10 divisions are showing 50 milliampere, so the least count is 5 milliampere. Your 10 divisions are showing 0.5, so one division is about 0.05 volt. Okay. Now we'll make the connections. First we'll take a cable and connect it to the positive of the battery supply to the resistance. This is the resistance. We are connecting it to the resistance. The resistance is automatically connected below the kit to the P side of the diode. This is the diode. And to measure the voltage across the diode, we will connect to the P side the positive of the voltmeter, and to the N side the negative of the voltmeter. Then we will take another wire and connect it to the N side of the diode to the positive of the milliammeter. Then the milliammeter negative comes to the negative of the supply. I'll show you the circuit diagram in a while. This is the milliammeter which is connected. Okay, now we need to switch it on. Keep in mind the knob should be at 0 position while you switch it on. Then if we increase the value of the voltage by turning the knob, you see the voltage is increasing but the current is not. Because why this occurs? Because of the depletion layer in the PN junction, that is the diode. The barrier voltage is not yet overcome, so there is no current. After a while the current will come. When the current comes, you take reading with respect to the current. You see now the current is coming. Now you take readings with respect to the current. See, there is a technique of taking the readings. Before the current comes, you measure only the voltage, and then you see the current is 0. So you plot 0 across the current axis and plot whatever voltage you plot along the voltage axis. Now see, till 0.5 there is no current. At about 0.7 the current comes, you see. At about 0.7 there is a slight deflection in the ammeter, milliammeter. Then after that, if you increase the voltage a little bit, there is current. Now you increase the current step by step and take whatever voltage reading you get and plot a graph between voltage and current. That will be the VI characteristic of the PN junction. See, at first there is no current because of the depletion layer. I will explain what is the depletion layer in a little while. So this is the experiment. You need to take about 10 readings. First 1-2 readings you take when the current is 0. Then after the current comes, after see 0.7 or something like that voltage, the current comes slowly. You see, look towards the milliammeter, the current is growing. Don't increase the voltage very much because it may damage the diode. So this is the experimental setup for the PN junction experiment in class 12. Okay, so this is the circuit diagram of the experiment that we just did. Here this is the variable voltage source. We connect the voltage positive of the voltage supply to the resistance. From the resistance other point, it goes to the positive of the voltmeter, and the N side of the diode is connected to the negative of the voltmeter, like the P side was connected to the positive, and the N side is again connected to the positive of the milliammeter. Then the negative of the milliammeter is connected to the negative of the battery. This is the entire connection. Okay, now let us go about what happens inside the PN junction. Why does the current doesn't grow? Why does the current not grow initially? That occurs due to the depletion layer. You see, when there is a PN junction, there are two types of semiconductor materials, impure semiconductor materials. Let us draw it in a big way. Wait. This is suppose one P type. This is suppose one N type. Okay. P type and N type are connected, joined together to form a PN junction. Now, in the P type, there are a lot of holes. That is the positive charge carriers, majority carriers in the P side. And in the N side, there are a lot of electrons. Majority carriers in the N side are electrons. There are a lot of electrons, free electrons, like which comes from the pentavalent impurity. In the hole comes from the trivalent impurity. Okay. So now when they are fused and joined together, these electrons near the junction, they jump to neutralize the holes. But originally this N side was neutral, this P side was also neutral. But now because the electrons have jumped to the left side, this side will become slightly positive. This side will become slightly negative. As a result, there occurs a voltage in this direction, which is called the barrier voltage. This voltage should be overcome to flow current in this direction. So if the battery is connected like this, the positive of the battery to the P side, there is a chance that this might be cancelled by the battery voltage. So if that is cancelled, you see this electric field of this positive and negative, it is positive this side, the negative this side. So electric field will be this side. Electric field pushes the positive holes towards this side furthermore, and it pulls the electrons towards this side even more. So they are not getting chance to recombine. So no current flows initially. But if you apply voltage greater than this barrier voltage, then there is a chance of current flowing. So once this barrier voltage is for silicon 0.7 volt, like we got in the experiment. So if you apply a voltage greater than 0.7 volt there, this is cancelled and these holes recombine with the electrons, and there occurs a flow of current that is called forward current. And the graph that you will plot will be somewhat like this, of the forward current and voltage will be somewhat like this. Initially there is no current. Minimum current is there because of minority charge carriers. I'll cover that in another topic. But after this, there is a current growing and then it gets saturated. Here this voltage is called knee voltage. It occurs due to cancellation of the barrier voltage. So this is the current in milliampere. This is voltage in volts. So if you plot like this, if you increase the voltage, there is no current initially, no y coordinate, 0 y coordinate, almost 0. That is, after that the current grows and it grows exponentially. So this is the PN junction experiment. I hope you have understood. Thank you.